All right, we're going to talk about section 6.1 from Algebra 2, which is simplifying radicals. Before we go do that, what you might want to do to help you out with simplifying radicals is know some factors rules, some divisibility rules. And I just went online and I Googled some divisibility rules, and I came up with these ones as the main ones. Really, the evens, the threes, um, the 2, the 3, the 5, those are the ones you're going to want to make sure you know. Makes life easier. Obviously, if it's an even number, it's divisible by 2. If you add up all the digits and that number is divisible by 3, then the number is divisible by 3. If it ends in a 0 or 5, you know it's divisible by 5. And then if it ends in a 0, you know if it's divisible by 10. The reason why I want to know these ones is just so when you're going and making your prime factor tree, which we've already done a little bit of, it can help you out easier. You're also going to want to know your actual perfect roots or your perfect squares and your perfect cubes as well. So like my perfect squares, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, so on and so forth. Keep going down. Your cubed roots, those ones are going to get a little bit bigger, are going to get a lot bigger, a lot faster. So first thing, 1 cubed is 1 times 1 times 1, 1. 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. You guys can see they start getting bigger really fast. And you go on from there as well. If you want to go to 5 squared, you get 25. 5 cubed is 125. And you keep going. You're going to want to be able to know some of those off the top of your head. So let's go back now and let's talk about what it means to simplify radicals. We did already talk a little bit about simplifying radicals, and we know some of these easily. So the big thing you could do, the first thing you could do is make your factor tree. So 2 and 2. Really, the square root of 4 is 2. Square root of 9 is 3 because 3 times 3 gets you 9, and the square root of 81 is 9 because 9 times 9 gets you 81. Well, now we're going to work on some trickier problems, though, ones that aren't so easy. So if we look here, square root of 27, remember, make your prime factor tree. So 3, 9, 3, 3, 9 crosses out, 27 crosses out. We have a pair of 3s, so 3 times the square root of 3 comes out. Now, what's not written under the square root is the number outside of it. So the square root, really what we're looking for is pairs of 2's. What two numbers multiply to get that? That's the opposite of a squared number. When we look over the cubed root of 27, that little 3 outside of the squared, or the root piece there, that means we're looking for the cubed root. That means we need groups of 3 to come out. So again, let's do this. We do 3 times 9, make your prime factor tree. 3 times 3. Now instead of circling groups of 2 like we did on that last one, we have to look for groups of 3. And notice we have 3 3's, so everything comes out. My solution is 3. All right, so let's try that again. Now we look over on this far right one, we have cubed root of 81x to the 4th. Again, make your prime factor tree. So I'm going to multiply this. It's going to be 9 and 9. I know that comes out. That's gone. Then we have 3, 3, and 3, and 3. Now with my x to the 4th, I know what that splits up to is 2, 4 x's. All right, now I want to look for groups of 3 within that. So I have 3 3's there, I have 3 x's there. Remember, if I have a group of 3, 1 comes out front. So 1 3 comes out front, 1 x comes out front. Then what stays inside is everything that's not circled. So that other 3 and that other x, this 3 and this x have to go back inside because they were not circled. Now, do you have to do that every time? No, but it helps you guys see where the things are. Now let's look down here. Just like we did before, inside times inside, outside times outside. So first thing I'm going to do is I'm going to multiply the outsides here. Now I'm going to get negative 12. And I'm actually going to pull that down and use it later, and I'm going to focus on the insides now. Because when I'm multiplying, remember, I could multiply through 20 times 15, the inside times the insides. I could do 20 times 15 and x times x squared. But first thing I'm going to do is I'm going to make my prime factor tree of each piece. So this is going to become 2 and 10, 2 and 5. This over here, the 15, I'm going to make it 3 and 5. That's going to cross out. My x is going to stay an x, but this x squared becomes x and x. So I'm going to pull that down and make an x as well, just so you can see it all in blue. Now I'm going to circle pairs of 2 of all my prime factor trees, because remember, if I multiply my inside times my inside, and maybe I should go back here. Really what this becomes is negative 12 times the square root of 20x times the square root of 15x squared. So again, we're going to do our inside times our inside. I'm going to put that prime factor tree back up. So again, just like we did before, what we need to do is, since we're square rooting, we have to find groups of 2. So I have two 2's there. Now we can reach across because we're multiplying the inside times the inside. So we can do the 5 times a 5. And over here I can do the x times the x. Now we have to look for what we can pull out. Well, I can pull out a 5. So I'm going to bring that down to my negative 12 that I had pulled out before. And I'm going to multiply times my 2 times my 5 and times 1x. And then what stays inside of my square root is the other pieces that weren't circled, which is my 3 and my x. So really now we have to multiply as we do negative 12 times 2 times 5. So really we get negative 12 times 10, which is negative 120x times the square root of 3x. All right, that next one over there on the right, the 2 times the square root of 5 times 3 times the square root of 15. I'm going to have you guys try that one quickly, and I'll put up the answer in a second. All right, you guys can check your work and check my answer here as well. Notice that I pulled down the 5 again. You don't have to do that. I just did that to show the work, so the colors stayed the same, so they were all in red there, and I could circle the pieces that went together. All right, now let's go on to the next piece. So combining like terms, remember that. So all we have to do is, if we have x squareds, they go together. If we have x's, they go together. If we have constants, they go together. So 3x squared minus 5x squared, well, they're the same, so we have negative 2x squared. The reason why we have to think about that is we have to look over to this right one. The square root of 18 plus the square root of 8. Are those like terms? No, they're not. The roots are not the same. But let's try to make them the same. So I'm going to make my prime factor tree here of each piece. And once I have those, I'm going to circle my pairs that I have. And I'm going to rewrite these now as 3 square roots of 2 plus 2 square roots of 2. Now if you notice, I have like terms because my roots are my terms in this piece. Those are the parts that have to be the same. I have 3 square roots of 2 and I have 2 square roots of 2, so this becomes 5 square roots of 2. So I want you guys to look at this last problem. It's a tougher problem, I know, but I want you to try it, and I'll put up the answer in a second for you. Notice I can't combine those any further because we have 2 cubes root of 2 plus 1 square root of 2. The square root and the cube root are not the same. They're not like terms. All right, now I'm going to show you how we write these in exponential ways, so rational exponents. So 4 squared, we all know what 4 squared is. It's really 4 times 4, so that is 16. 9 squared is 9 times 9, which is 81. And 3 cubed is 3 times 3 times 3, which is 27. Well, now we have to go and we have to think about the opposite. So if I have 9 to the 1/2, really what this is the same thing as, 9 to the 1/2 is the same thing as this, or sorry, 4 to the 1/2 is the same thing as the square root of 4. So 4 to the 1/2 is meaning the same thing as the square root of 4 because it's a reciprocal. That means the opposite, right? That's why we do the square roots when we do the opposite of squareds. They cancel each other out. So really, what we end up with here is 2. Same thing is for 9 to the 1/2. That's the same thing as the square root of 9, which we know the square root of 9 is 3. Now cube root, that's the opposite of cubed. So really, or sorry, 27 to the 1/3, I gave it away, is the same thing as cubed root of 27. So again, we look for what 3 numbers multiplied by itself equals 27, and we know that one is as well 3. So fractions, that means it's going the opposite. So if I have these written in exponent notation, I'm going to rewrite these in radical notation. So what I mean by radical notation is that I need a square root, a cube root, a fifth root, some root in there as well. So there's really two different ways I can rewrite these. So I'm going to change this to be 5 to the 1/3 squared. So this is the same thing if you remember your rules of exponents. So then really I can rewrite this as the cubed root of 5 squared. That's one way I could rewrite this. I could also rewrite this as 5 squared to the 1/3, which is really the same thing as the cubed root of 5 squared. Now when you're going to do each way, again, it kind of depends on what numbers you have. If it's just saying simplify, normally what you do is you're going to write it in the way with the root on the inside and the the power on the outside, the higher exponent on the outside. So what I mean by that is the general way we're going to write this is we're going to rewrite 6 to the 2/5 as 6 to the 1/5 squared, which really means we're going to take the 5th root of 6 and square it. So 12 to the 1/2 is really the same thing as 12, the square root of 12. Now we don't write the 2 inside of the square root because it's such a common one that we've just learned to just use it as just without a 2. So don't worry about writing the 2 in there. All right, so now this is what I was talking about when I said it depends on which one you're going to do on which one's easier. So if we look at this, I'm going to rewrite this guy as 81 to the 1/2 power cubed. And the reason I'm going to do 81 to the 1/2 power first is because if I look over at the other option, I have 81 cubed to the 1/2 power. Now in your head, can you do 81 times 81 times 81? I don't think you can. But I do think you probably can do this piece because this is really the square root of 81 cubed. And the square root of 81, well, we all know the square root of 81. It is 9. And all we have to do now is 9 times 9 times 9, which is 729. Much easier than trying to figure out what the square root of 81 times 81 times 81 is. All right, let's do another one. Again, I don't want to do 125 squared, so I'm going to do the cube root of 125 squared. Well, what three numbers times themselves get you 125? Well, let's figure that out. 5 times 25, 5 times 5. So we can look, oh, it's a perfect cube, so really this becomes 5 squared, which means 5 times 5, which easy peasy is 25. All right, let's do a trickier one over here. And the reason it's trickier is because I can't simplify everything the same way. We'll go over this and I'll show you what I mean. So I'm going to try to take the cube root first. And I can take the cube root of 8. So if you already know that, it's okay. So I can take the cube root of 8, but I can't take the cube root of x squared. So this is going to become 2 cube roots of x squared squared. So now what I'm going to do right here is I'm going to change it from cubed root or the cube root of x squared. I'm going to change that to 2 times x to the 2/3 power squared. And the reason I did that is because it's a lot easier to distribute that squared through to each piece. So now we're going to use our power to our power, and we're going to get 2 squared times x to the 2/3 squared. Multiply those, so really what we're going to do is we're going to put it over 1, 2 times 2. So we're going to end up with 4 times x to the 4/3 power. Now depending on how you start is how you probably should end. So since we ended with a radical in there, I want to end in a radical in my last problem, or my solution. So really this becomes 4 times, and I'm going to put the cube root on the inside, cube root of x to the 4th power. Now another way you could do this, and actually how the best way to do this would be, is to do 4 times the cube root of x to the 4th power, because now you guys can actually look and you can see, well, I have 4 x's, which means I can pull out a 1x. So really this becomes 4x times the cube root of 1x left. That single x comes back down inside. So that would be our fully simplified version right there, making sure that that q, or that 3, that's with our cube root there, not with the x there. All right, remember negative exponents. What that means is right here I have really 1 over 3 to the 4th power. So we can multiply that through 3 times 3 times 3 times 3 times 3, and we could get 1 over 243. Now this next one, this is going to be a little bit trickier because really this is the same thing as the square root of 2 to the negative 1, which really means that we end up with 1 over the square root of 2. Remembering our rules of exponents, we can't have a square root on the bottom. So I need to multiply by the square root of 2 over the square root of 2, which gets me the square root of 2 over 2 is my actual simplified version of that. And the last one over here, that negative 2 is only with the x because it's not in parentheses, so it becomes 4 over x squared. All right, I'm going to do a couple examples really quickly here for you. Make sure you're following along and doing your best to do these as well. So Again here, I'm going to do the square root of 16 cubed, which is really 4 cubed, which is going to be 64. All right, now we have the square root of 9 to the negative 1, which is really 3 to the negative 1, which is 1/3. And over here, we really have the cube root of 27 to the negative second, so it becomes 3 to the negative second, which is 1/9. All right, I want you to try these other 3 down here. Or actually, let's do all of them. I want you to try these last 6, and I'll put up the answers for you here in a second. All right, here are my solutions. Notice I did skip a couple steps when I did like the green there where it's 2 to the negative third. I just did my 2 to the third and I put it on the bottom. Same thing with the orange and with the pinkish color in the bottom right there. All right, now let's do a couple problems where we're doing it the opposite way, where we're giving it a radical form, and let's solve these. Again, remember, make your prime factor tree. You might already know what the 4th root of 81 is by this point, but we know it's 3 times 27, 3 times 9, 3 times 3. So we need to look for groups of 4. So really it becomes 3 to the negative first power, which gives us 1/3. All right. Again, 4th root, make our prime factor tree. 2 times 8, 2 times 4, 2 times 2. Again, you may already know your 4th root of 16 real easily. So this becomes 2 to the 5th power, which means we do 2 times 2 times 2 times 2 times 2, which is 32. All right, I'm going to leave these 4 up here for you guys to do quickly. Let me know if you, or do them quick and I'll put up the answers here. All right, here are the answers I got. Notice in the orange and the purple ones, I didn't simplify any further. I just rewrote those as exponential form. Some teachers might have you simplify it by doing the squared first and then taking the cube root, or doing the 5th power first, then doing the square root. I would just leave it as that form right there. Notice also in the blue there, when I take the cube root of a negative number, I'm going to come out with a negative number. You can cube root, you can 5th root, you can any odd root negative numbers. You'd get imaginary numbers if we use even numbers. So remember, you can actually do those without getting imaginary numbers when they're negative, and it's a odd root, and you know your answer is going to end up having to be negative as well. Now the whole reason we're doing these is to figure out solutions like this. We're giving you an actual equation, now solve it. So what do I do to get rid of a cubed? You do the opposite. So to get rid of a cubed, you're going to do the cubed root. Because remember, cubed root is really like raising to the power of 1/3. So if I raise this to the power of 1/3 and I raise this to the power of 1/3, really what happens there, exponent to an exponent, they cancel out, so you're left with just x to the first power. And that's what we want. So let's figure out what 3 numbers multiply by themselves to get you 64. Well, I'm going to take out 4, we get 16. I know 4 is not prime, but I know that 16 times 16 is, or 4 times 4 is 16. So my x equals 4. Now it's only going to be positive 4 because of the fact that it is a odd number. Now let's go over here again. So first thing I'm going to do is multiply by 2 to get rid of that half. So we get x to the 5th equals 128. Now I need to do this 5th root. So to raise to really to the 1/5 power, to the 1/5, to the 1/5, which means that's really x equals the 5th root of 128. And now I'm going to do my prime factor tree here. So I get 264, 232, 216, 28. I'm going down here, 24, 22. So I need 5 of them. 1, 2, 3, 4, 5. So we're left with 1 comes out and 2 stay inside. So that means that x is going to equal 2 times the 5th root, almost said square root, of 4. So make sure you do it in radical form there. Leave it in your answer in radical form because that is your actual exact answer versus being your approximate answer. All right, I'm going to do one more problem because of the fact that we have the squared in here. That's going to change things up. So first thing we do, divide by 3. So we get x squared equals 36. Now, this is why I'm saying that you have to make sure you're paying attention where they're odd or even, because technically you're going to have two solutions here. If I square root both sides, well, really, I can get x equals 6 or negative 6, positive or negative 6. So when you have that even number, you need to split it up to be two answers. When it's an even exponent, sorry, you need to split it up to be two different answers. It's the positive or negative version of that. So I'm going to let you solve these last two. Actually, I'll do the left side, you guys do the right side. So let's do this one first. Cube root both sides. To get rid of that third power, x minus 2 to the third power, we need to get rid of it. So I'm going to cube root both sides. Cube root both sides. Those cancel out. And I can't take anything out of that because it's just 2 and 7. So I'm going to leave it there. So really we're left with x minus 2 equals the cube root of negative 14. Now, all I can do is get rid of that plus 2, so I'm going to change this to x equals 2 plus the cube root of negative 14. Now, really, when I add 2 to both sides, I would get x equals the cube root of negative 14 plus 2 is the same thing, but I want to put my radical last, so that's why I'm going to write it that way. All right, I want you to try those last two on the right by yourself, and I'll show you the answers here in a second. All right, here are my two solutions. You can notice the first one only has one solution because it's an odd exponent. So I'm cube rooting, which means that it's only going to be one answer, because if I put negative 2 in, I'd get negative 8. And my final solution would be negative 2. The second one, I have two solutions because it's a fourth power. So because it's a fourth power, I can put a positive or a negative version in there. So that means that 2, when I get down to x plus 5 equals, it'll be plus or minus 2. I have to solve for each piece. All right, let me know if you guys have any questions. This is going to be all for this section. Sorry, the video was a little bit long, but let me know if you have any questions about your simplifying radicals.